Hi, I'd like you to pause the video and try these questions, and then I'm going to talk about each of them, but make sure you try them. We got rearranging equations, we've got some trigonometry, and we've got finding the equation of a straight line. Okay, here goes. Here are the answers. So we can rearrange equations by doing the same thing to both sides. And here I would minus 3x from both sides. When I minus 3x, these cancel, and I'm left with y is equal to 4 minus 3x. This is conventionally how you write it. You would write the minus after. You could write it as minus 3x plus 4, and we'll talk a bit about why you might want to do that. But either of those answers are fine. The next one, because we've got 10 lots of y, it's a bit like when you're solving an equation. 10y equals 20. Well, y is 2, but how do you get that? You do 20 divided by 10. Same process here, but we've got a formula instead of like an equation to solve. We're going to get y is equal to 5x minus 20 all over 10. Now there is another, like you can simplify it further, or at least, I don't know if it'd be called simplifying, but write it in a different form. And I'm going to go to the top right for that. You could actually write it as 5x over 10 minus 20 over 10. Basically, I've done the opposite of when I add and subtract fractions. When the denominator is the same, when you're minusing or adding fractions, you can put it together. Here, it is together, so I'm just separating it. Why would I do that? Because now I can actually write it as 5 over 10 times x. You're allowed to do that when you're multiplying two numbers together, like a fraction and an integer. You just multiply the top by x. I'm just undoing that. And here it's 20 divided by 10, so it's 2. And then finally, 5 over 10 is just a half, so it's actually a half x minus 2. Now, if you left it like this, then that's still, I'm happy with that. But again, we'll see in a bit why you might want to write it like this. And the last one, a few steps to do now. So first of all, add 4 to both sides and minus 3x from both sides. So it's going to become 4 minus 3x. And now we're back in the situation we were for part B. So I can write y is equal to, but this time I'm going to I'm going to do it more quickly. I'm actually going to, instead of putting it all over 5, I'm going to divide the 4 by 5, and I'm going to divide the 3x by 5. But I'm going to go straight to writing it as 3/5 x. So I've done this the quickest out of all the questions, but I've used what I've explained in the previous ones. So again, if you left it all over 5, I'm okay with that, but we'll see why this is a really useful form in a bit. Okay, second question. This is right-angle trigonometry. So I've got my hypotenuse, and I've got my adjacent. I've got SOHCAHTOA, and I'm trying to work out the hypotenuse. I know the adjacent, so it's going to be CA. It's going to be CA, which means cos of the angle, in this case 56, is equal to the adjacent over the hypotenuse, which in this case is 7.4 over x. That's what I can write down. This is one of those trig questions where you don't just end up multiplying them because x is on the bottom. So this, the reason I put this in is it again is getting you to think about rearranging equations. I need to multiply through by x, and then I need to divide through by cos 56. Sometimes people just learn, oh yeah, I'm going to divide by it because x is on the bottom. Sometimes people kind of learn a triangle method for SOHCAHTOA. It's not actually like that. You know, and you cover the one up that you need to find, so it's adjacent divided by cos. But ideally, what you do is you learn how to rearrange equations. We get 7.4 divided by cos 56, and at that point, I put it in my calculator. Sorry, 7.4. Yeah. Okay, 13.23, which I might round to 13.2 centimeters. Okay, good. That trig question's done. Okay, finally, the straight line L is shown on the grid. Find an equation for L. this is back to y equals mx plus c. So I can work out the value for c really quickly. It's the y-intercept. It's -1. I can work out the gradient by drawing a little triangle going from one corner to another corner. I go along 2 and up 1. My rise over run is 1 over 2. And then the equation just falls out. Y is equal to a half x minus 1. Today we're going to look at equations where it's not in the form y equals mx plus c, but we can put it in the form y equals mx plus c. And actually the 3 questions we did in the starter are all examples of this. They can be written in the form y equals mx plus c. And this is what I was hinting at when I was talking about the fact that we could write it as a half x minus 2. Because then you can just read off the gradient and the y-intercept. You can't do that if you just leave it as 5x minus 20 over 10. It's much harder to see. So I suppose what I'm going to say is, now that I've gone through that starter question, can you try and reproduce what I've said and try to work out the gradient and y-intercept of each of these lines? Otherwise, I'm going to go through it from scratch now. So for the first one, I can just minus 3x from both sides, and I'm going to get 4 minus 3x. And that's absolutely fine. The reason I said that sometimes we write it as minus 3x plus 4 because it is then in the form y equals mx plus c. And actually, the gradients, I'm not going to write gradient, I'm just going to write m and c. The gradient's going to be minus 3, and c is going to equal 4. Sometimes people think, oh yeah, it's the first thing that's the gradient, but it's not. It's the thing that's in front of the x. That's the important bit. So I'm done. I can, when I first look at this, I might think the gradient is 3, but no, I need to write it in the form y equals mx plus c. Next one. This is when I said, well, we can divide by 10, and that's all good. We've made y the subject. However, sorry, that should have been a 20. However, we've not got it in the form y equals mx plus c, so we can't just read off the gradient. We've got some extra steps needed. And we can do that by, like I did before, separating the fraction and then realizing that I can write it as 5 over 10 times x. I want to say a bit more about this. So if I have, I don't know, if I have 4 over 2 times 8, then that's 4 over 16. Hold on, I'm doing this differently to what okay, let me try this again. So 4 times 2 over 8, that's a good one. So this is going to be 8 over 8, it's going to be equal to 1. Now I could also write it as 4 over 8 times 2, and that would be a half of 2, that would also equal 1. The point is, it doesn't matter whether I do the division first, I do 4 divided by 8, or if I do the multiplication first, I do 4 times 2. I will get the same answer. So this is the principle I'm using here. Rather than doing 5 times x and then dividing by 10, I can do 5 divided by 10 and then times by x. And I can do 20 divided by 10, that's going to be 2, and I'm nearly there. Then I can simplify it to a half x minus 2. And again, I've made it in the form y equals mx plus c. So m is equal to a half, the gradient, and c is equal to minus 2. And the very last one, I know I talked through this one quite quickly. I'll go for it a bit slower here. So first of all, actually, is it? Okay, it's in a slightly different form, but that's okay. They've kind of done part of it for us. They've already got the 4 on the right hand side. So I'm going to minus 3x from both sides. It's going to become 5y is equal to minus 3x plus 4. And I'm writing it as minus 3x plus 4 because I'm already trying to get it in the form y equals mx plus c. And then I can divide through by 5. So it's going to become minus 3x plus 4 all over 5. But now I can use the same steps that I did before. So it's going to become minus 3x over 5 plus 4 over 5 by separating the fractions. And then finally, I can use that little trick I just used a second ago to give me minus 3/5 x. Okay, I can do the division first and then the multiplication plus 4/5. Why does that help? Because now I can straight away write down that m is equal to 3/5 and c is equal to 4/5. So this will come in useful. Just from a viewpoint, if I wanted to, one viewpoint, if I wanted to draw any of these lines, it's going to be useful potentially to get them in the form y equals mx plus c, because then I can draw them. And one other thing we're going to look at today is I can now start looking at whether lines are parallel or not. Like, is this line parallel to this line? It's very hard to see from these two equations, but once we've got it in the form y equals mx plus c for both, we can see no, they are not. This one gives me a gradient of 1/2. This one gives me a gradient of minus 3/5. So we've talked about this process of rearranging an equation into the form y equals mx plus c. If you're still not that confident, then I'd say, well, practice today, but then go away and practice a lot more rearranging equations that will come together. It's this principle of balancing equations. It's the same thing you do when you're solving equations. It's a really important algebraic process to get your head around, to be able to access like more complicated areas of maths. The rest of this lesson, we're just going to be practicing, the similar sorts of things, but bringing in previous topics as well. So I'm going to pause the video at the start of each little mini task, and then I'm going to talk through them, show the answers and talk through them. So here, can you tell me the gradient and the y? This should be the y-intercept of each of these lines. Okay, I'm going to show you the answer now. I haven't got all the rearrangements, but here you go. This is what would happen. And which two equations have the same gradient? I've highlighted them in green. And this is the point. You wouldn't necessarily look at this one and think that they have the same gradient when you first see it, but there is 1/2 for both of them. And they're similar with the y-intercept. It's these two that have the same y-intercept. This is a slightly more wordy question. Show that these lines are parallel. Well, to do this, okay. First of all, pause the video and try both of these. So we see for the first one that m is equal to 2, and the second one I need to write down that 4y is equal to 8x minus 6, and then I can jump straight to y is equal to 2x minus 6 over 4, which is 3 over 2. I've literally divided this by 4, which gives me 2x, and then 6 by 4, which can be simplified to 3 over 2. So, show that they're parallel. You just need to write a conclusion. Same gradient, so they are parallel. When you get show that questions, you must like give a conclusion. Okay, next one. So this is bringing in a previous topic. We're told that the equation of a line passes through a point and is parallel to some other line. In the past, we've had it in the form y equals mx plus c, so you just read the gradient straight off. But now we've got just a little bit extra to do. It's going to be y is equal to minus 2x plus 3, and that is enough. We get the m is equal to minus 2, and then it turns back into being one of those problems where we have the gradient and we have a point that goes through it. So I'll quickly talk about this one. It's going to be y is equal to this is the parallel line now. Y is equal to minus 2x plus c, same gradient. I should have probably said that this is the original line and this is the parallel line. Because now I can sub in the points when x equals minus 1, y equals 1. So 1 is going to equal 2 plus c, because it's minus 2 times minus 1. C is going to equal minus 1, and I'm done. Y is equal to minus 2x minus 1. Okay, I don't. This is not correct at all, so ignore that one. I'm definitely right here. We can check. Like, we know the gradient is minus 2x. I can see that when x is minus 1, it's going to go through 1, so I'm 100% happy with that. My answer's like tricking me here, but that's not correct. Okay, what about this task? Determine which are parallel and justify why. Here are the answers. So the gradients, this is a sort of explanation I would expect to see. The gradients are not equal. Here they are. Here they're not. This is a special case. Remember, these are horizontal lines, so they do have the same gradient and they are parallel. These two are, and these are not. Very, very close to being, but every single time try and write them in the form y equals mx plus c. Okay, and finally we're getting on to some later questions on this topic, but it's the same kind of principles and using things we've had before. Find the equation of the line that passes through 2, 4 and is parallel to this one. That is a similar question to that. Okay, so the original line is going to be y is equal to 3x plus 5. So the parallel line will be y is equal to 3x plus c, because it's the same gradient. When x equals 2, y is equal to 4. So 4 is equal to 6 plus c. C is minus 2. And we get y is equal to 3x minus 2, which I think was the answer from above. So it's just practicing that a little bit more. And then this one here. Sometimes you see questions that link in previous topics, like equation of a line through 2 points, to something like this. So we need to be able to deal with that. Okay, let's look at line A. We're going to get, this time we got the minus 4y. So my advice would actually be add 4y to both sides. So 3x is equal to 4y plus 5. Then minus the 5 and swap the sides around. 4y is equal to 3x minus 5. Y is equal to 3/4 x minus 5 over 4. You could have instead minus 3x from both sides and then divided through by minus 4. I just think there's more opportunity for errors when you start dealing with negatives. So m is equal to 3/4. And now I've got line B. So we're given 2 points. However, you don't need to work out the whole equation of the line. We only are interested in if they're parallel. So I can work out the gradients by doing y2 minus y1 over x2 minus x1. 3 minus 7 over minus 1 minus 4. And that gives me minus 4 over 5. So they're not equal. Not equal. So they are not parallel. And finally, this question is actually, it's a bit like the super challenge I gave in my lesson on finding equations of lines through 2 points. But instead of it being general, I've now got it in terms of P. So it's a bit nicer, but it's still very challenging. Have a go. Okay, first things first. M is going to be y2 minus y1 over x2 minus x1. So just look at the negatives and be really careful. I put a bracket around here because I'm minusing the whole thing. This becomes 3 minus 3 plus 6p. And down here, this becomes plus 2, which cancels with the minus 2. And additionally, the 3 minus 3 cancels, and then I get 6p over 2p. The p cancel, and I'm left with 3. So I've got a nice gradient from that coordinate. Then I can write down that y is equal to 3x plus c, just like before, and substitute one of the points in. It doesn't matter which one. Let's put in, I don't know, let's put in the x one. Probably the x one's a bit nicer because then it's 3 times minus 2 rather than being 3 times all of this. So I can put that in. 3 minus 6p equals minus 6 plus c. And that means that c is going to equal 9 minus 6p. And I'm basically done. Like, the answer will be in terms of p, it will be y is equal to 3x plus 9 minus 6p. I can't simplify that anymore. I could check that it works. So when x is minus 2 plus 2p, does it work? It will work. And if you're happy with that, then you're in a good place. So basically, you want to be able to deal with questions like this now. So you might have to deal with 2 points, and you might have to deal with a rearranging, and we can deal with ones like this, and we can basically say when equations are parallel or not. Okay, good effort.